So I'll be talking about maps, maps and more technical subjects, such as CSS for maps, JavaScript for maps, and WebGL and that kind of stuff. My name is Erik. I'm currently living in Spain. I'm French originally. And well, usually you start with a bio, and I decided to do the full thing and start when I was 6 years old. So I was this guy. And as a child, I was really into maps. I was really like spending whole holidays drawing maps of imaginary islands and that kind of stuff. I even have some photographic evidence of this, so I'm not lying. And then all of a sudden, my parents bought this. It was the 486 personal computer. And then all of a sudden, I've stopped drawing maps and I started doing other things. I discovered internet, and you know, I've started playing with it and just forgot about maps for a time. And then fast forward to a bit later, a few years ago. I was a freelance developer, and that was the kind of stuff that I was doing. This is an interactive wall for the latest Volkswagen SUV. I wasn't really into this at some point. I mean, I was doing some cool stuff, some augmented reality, some virtual reality. I did some cool projects as a freelancer. But, I mean, at some point, you start asking yourself questions on why you are doing stuff and what you really want to do professionally. So, and also, I have to mention that when you're young, you do things that you came to regret later. And this is the thing that I regret heavily. I've been doing Flash development for a few years before the whole ship kind of sunk. And also made me think about open source versus closed source and that kind of stuff. And I thought bad about that little guy that I was when I was 6 years old and making maps. And I had a few years ago, I had a look of what was new in the area of cartography and maps in the web. And I saw a lot of different stuff. The last years, a lot of stuff is happening in cartography. The technology is evolving really fast. It's really interesting. And I mean, in pop culture, maps have never been so present and so visible. So what I did is I bought a whole lot of books. I know a lot of you guys do that. Sometimes you don't read them, but it's nice to possess them, at least. You know what I mean. And so fast forward a little bit again to now. I'm now working for CartoDB, which is one of the important players in maps, in mapping, in web maps. And for those who don't know, I'm not going to do the whole pitch, but basically CartoDB is an editor online for maps, data visualization, thematic mapping, geospatial analysis and that kind of stuff. And the editor is built on top of a whole series of APIs, which allows you to basically do something similar if you want. And all of this is open source, which is the reason I'm happy to work there. And so here I am now talking about maps at Frontend United. Yeah, I forgot about this, but you can follow me on Twitter. It's @Erik. And I cannot start a presentation about maps without a bit of history first. In 2005, Google released Google Maps. Looked like that at the time, and now it's a bit more evolved, but it was a revolution in terms of use, in terms of user experience, but not only. There were also two technical, very important revolutions in terms of web mapping. The first one is the map tile, which appeared first in Google Maps. So a map tile is just really simple block of technology. It's actually just 200 by 56 square. And stitched together, it composes most of the maps that you see now on the web. And it's a very simple idea, actually, that you can see in action here. But it allows for a lot of stuff. Preloading, caching, lazy loading, all kinds of strategies that wouldn't be possible if we weren't stitching those little images together. And yeah, by the way, there's this maps where you can zoom and pan. It's called a sleepy map. And so yeah, tiles, basically you got a tile set per zoom level. So at zoom 0 you have the whole world in a small PNG, and then the further you zoom on, the image is split into 4 parts, and again for every zoom level. So you can imagine that at zoom 18, that's a lot of images. And I mean, there are really interesting strategies around, the fact that most of the tiles that you will encounter are blue squares because it's the ocean. And it's really interesting to see how strategies are built with that kind of issues that are just related to the way our planet is made. So here's how it looks at zoom 13. And just a piece of information that is important is most of the time tiles have a sort of a URL schema with they have like a permanent link, a permanent URL, and basically you have a tile server and then the zoom level and then X and Y coordinates. So tiles are truly the foundation of web maps. They were and they still are, although in a bit of a different format, but I'll talk about this later. So second Google revolution is Web Mercator, and when I'm talking about Mercator, I cannot not mention projections. So as you maybe already know, the flat is a sphere. Sort of. It's actually not really a sphere, but and to represent the Earth in a 2D plane is a complicated operation. It's a mathematical operation, and it's a lossy operation. So you always sort of will be distorting areas or making some areas bigger and some areas smaller. And the projection that we are familiar with is this one. It's the Mercator projection. But there are other ones that are more suited depending on the area of the world you are showing. So for instance, this is an Albers projection, which is ideal for North America. Strange projections made by weird German guys three centuries ago. There's a lot of different ways to represent the world. And this one is very interesting because it's a polar projection and it's showing areas that are actually not on the standard Mercator projection. And yeah, also north and south are relative concepts, so keep that in mind. It's also a very political issue, but I'm not going to go further into this. And yeah, just to show the deformation that occurs when you're projecting the Earth in Mercator. So back to our good old friend Gerardus Mercator. He gave the world his most famous and most used projection, this one. And this projection has many disadvantages. For example, it shows Greenland roughly the size of Africa, while in reality it's 7 times smaller. So it has many disadvantages, but still it's the one that is the most widely used. And Mercator was a Flemish guy. He was living there, so thanks. One thing interesting to mention is that he made his projection for navigation originally. Because it has a property that constant bearing lines are straight lines. And the funny thing is that he never saw the sea, but still. And the funny thing also is that it's a projection aimed for navigation, but we are using it for everything now. So back to Google. What Google did is take the Mercator projection and did a more rational version of it, where basically they put the Earth in a square, like this. And that makes a whole lot of things more easy. And it's a fact. I mean, the standard map that you see on the web puts the world in a square. If you put the extent of the world, you're going to get a perfect square. Which brings me to latitude and longitude. Most of you probably roughly know what it is. A refresher for those who don't. And roughly, I mean, latitude and longitude corresponds to y and x, respectively, coordinates in a Cartesian plane, with the origin somewhere in the middle of the ocean. And what's going to happen when you do a web map is that, for example, you're trying to put a marker in Paris, and your marker ends up here. That's because you messed up latitude and longitude. And this happens very, very often. And the reason for that is that nobody agrees on whether we should put latitude and longitude in which order. And it's a very common mistake, one that you will do your whole life if you're doing maps. It's basically the equivalent of, I don't know, forgetting a comma or something like that. And why is that? So why does modern JavaScript libraries and file formats diverge on this? One of the explanations was that latitude was made possible to determine very early, while we took a lot of time to be able to determine longitude for many reasons. But until the 20th century, we weren't able to determine longitude exactly. So that's one explanation, and it's nowadays it's almost like a troll. I mean, nobody agrees, and nobody's right. Personally, I'm in favor of putting longitude first because X and Y, which to me makes sense, but nobody agrees. So switching to a different topic, Google Maps is awesome. I mean, technically they did huge advances. It's really impressive. So why would you care about anything else? Well, for three reasons. First, Google Maps, the client, the JavaScript library is closed source. So basically you have a big blob of JavaScript. It's really hard in practice to work with this. Second is that the license is actually really restrictive and you cannot do whatever you want with the data that are on Google Maps. And third one is neutrality. So for example, the boundary between India and China, depending on whether you're watching at the map from the US, from China or India, you're not going to see the same information, and that's a problem. And so, introducing OpenStreetMap, the Wikipedia of maps, same as Wikipedia, people are doing the map, are adding geographical information on it, and for example, they're doing this in Carto parties. So for example, here it's in Japan. They gather and they map the streets, what they see around them. So it's a very social thing. It's really interesting. And the result of this is probably the most complete map the world has ever seen. And it has evolved tremendously the last years. It's really, really impressive, the amount of data that is on OpenStreetMap. And if you compare with Google Maps or other map providers, in many areas of the world, it's much more complete. And it has information you don't even suspect. Like, for example, if you look at Disneyland, you're going to see all the roller coasters mapped. And this is the only visible part of the iceberg, because not all of the data of OpenStreetMap is shown on the rsm.org map. So there are many other stuff, ski lanes, I mean, lots of stuff. And OpenStreetMap is now commercially used. It's a viable alternative to Google Maps. Pinterest is using it, for example, amongst other. It's also used to produce art and that kind of stuff. The only thing with OpenStreetMap data is that you can do whatever you want with it, as long as you mention that it's OpenStreetMap. But the data is almost 1 terabyte, the planet file, as we call it. I like how they state that it's a big file. Yes, it's kind of a euphemism. It's a pretty big file. So, and working with it is a pain in the ass, to be honest. But if you want to play with this data, there's this thing called Overpass, which is an API that is available for you to run queries against OpenStreetMap data. It makes stuff really easier. So all of this is theory. Now let's put that a bit in practice to something. An area that I'm familiar with at CartoDB is data visualization or thematic mapping in the area of geography. So what is that for? 3 reasons. First, communicate an ID. So if you're the French Communist Party in the 40s, that might be your goal. And if you're Google, you want to show those are the Google queries for Donald Trump a few months ago, and it really carries the idea that Donald Trump is in the minds of people. Second objective is to tell a story. This one is a very known one. It's an old one from a French guy, and it's picturing the advances of the Napoleonic troops in Russia. And I mean, the story is obvious here. He lost. And I don't know, the thickness of the line is representing the size of the army. And the beige line is the going to Russia, and the black line is going back to Russia. And yes, you can see there aren't many soldiers left. A more modern story maybe is all the possible scenarios of escaping Alcatraz. It's a pretty interesting modelization. And it's a story of what ifs, which is also interesting. It's not what happened, but what could have happened. And the third objective is to analyze, investigate, and make decisions. Also a very old one from a guy named Jon Snow, really, I'm not kidding. And this guy was the first one to, he was just a doctor, he wasn't a cartographer, but he had the idea of putting on a map all the cases of cholera in London in the 19th century. And this led to the conclusion that some wells were poisoned, were contaminated. And it's also the first case of humanitarian mapping. So it's really like an important one. A more modern one, it's mapping Zika virus and the potential propagation of the Zika virus in the United States. So you want to do this, you want to show, you want to build a data visualization. Most likely you're going to use a library, a JavaScript library called Leaflet. And Leaflet is kind of the jQuery of web mapping in the way that it makes cartography accessible to everyone. And it has been built by this awesome Ukrainian guy who also happens to have a band, which is really good. And really, in a few lines, you can put a map on your website. It's really made for developers who are not familiar with any cartographic concepts. It's very simple to use. The one big strength of Leaflet is the ecosystem around it. There are really a lot of different plugins, and you can do amazing things with them. I have to mention that Leaflet is not the only solution. The historical one is called Open Layers, but it's a much more complex sort of Java-like API. So probably not the best choice to begin with. And so what Leaflet does is construct a map with what we call the base map, which will give context to your data visualization. And then on top of this, you're going to put data layers, so points, lines, polygons, and whatnot. And Leaflet allows you to do this. There are other tools to do more complex stuff, and those would be my favorite ones, but there are also many other choices. You probably already know D3, which is also useful for not maps, like charts and that kind of stuff, all data visualizations. And Cartodb is specialized in maps. You can combine those three, use only one, use two, use three. It's really mix and match. I really love PostgreSQL and PostGIS. PostGIS is a geographical extension of Postgre. It allows you to calculate areas of polygons, to calculate distances, buffers, and more advanced geographical stuff. What I like about SQL is how terse it is and how expressive it is. So what you would do in a lot of complicated lines of JavaScript, you can express that in very simple statements. And so, for example, this one is creating from scratch without any data, that kind of maps. Well, the metro line is already there, but and yeah, so it's really expressive. A more complex example is creating a density map, so points from areas. And yeah, so okay, I can go on and on, but I really like SQL. It's really, I'm a front-end developer originally, so for me it's pretty new, and I feel like God, to be honest. It's really powerful. And one extra thing that makes it even more powerful is a thing called CartoCSS, which is a Sass-like language to style maps. It was invented by guys at Mapbox a few years ago. And you will find many things that you're familiar with if you're doing Sass. Selectors, variables, selectors based on a value here. You can also style depending on a zoom level, which is shown here. You can do many things. It's really powerful, and basically it will allow you to style lines, polygons, and points. It also has blend modes, so you can do that kind of stuff. And at CartoDB, we're in the process of extending it to add the possibility to generate color ramps automatically, so that you don't actually have to define colors, but you just give a general theme, and it will map to your values with a classification method on just one line. And it can do really a lot of stuff. It can do filters for blur and that kind of stuff. Complex text rendering. It has text placement algorithms, which is really important in cartography. SAS-like color methods, so lighten, darken, etc. It can do animation with CartoDB at least. You can have multiple layers. You can do binning, which is putting data, scattered data into a single point. A lot of stuff, which makes you a really powerful mapper now. The only thing is that you're going to have to deal with file formats, and it's really a pain in the butt in the world of cartography. Those file formats have to describe geometries. So again, points, lines, polygons, even arcs. And the easiest one is GeoJSON, which is handled natively by Leaflet and by all mapping libraries. It's easy to read, it's easy to parse. It's maybe not meant to edit by hand, but at least it's easy to read. The only thing you have to be aware, though, is that GeoJSON have coordinates with longitude first, while Leaflet has latitude first, and it will lead to a world of pain all the time. So it's one thing to keep in mind. If you want to get familiar with the format, there's a really nice tool called GeoJSON.io, which will allow you to draw stuff on the map and see the results in GeoJSON. Also, interesting to know is that if you put a GeoJSON file in GitHub, you will directly see it on the map, so it's pretty useful. Another format, very different, is the shapefile. It's the grandmother of geographical formats, and it's actually a zip file containing binary files. You're not going to be able to handle this with Leaflet directly. Again, with a lot of XML formats, the OpenStreetMap format, the GPX format, which is the one produced by your running watches, that kind of stuff. KML format, the Google Earth format. CSV will be your friend. It's brutal, it's really rough, but it's very useful and very easy to manipulate. All of that stuff, if you have something that can convert all those data formats, it's going to be really helpful for you. CartoDB is an option, but there are many. There's a solution at Mapbox called Omnivore, I think. And yeah, the idea is that you easily go from this format to a map. And yeah, sometimes the data you want is in an HTML table. Then you will probably use Cheerio, which is a version of jQuery for Node. And geocoding is also a problem. Geocoding is when you have places, names, or addresses, and you want to turn them into coordinates or polygons. There are, again, many ways to do it. Google has an API to do that, but keep in mind that you're supposed to use that on top of a Google Maps as per their terms of service. And I want to talk again about tiles because things got modern a little bit, and we are not talking about vector tiles. This is what you see when you go to Google Maps. You can see that you're not seeing small pictures, small PNGs, but rather a continuous set of geometries. And the way it works, if you open the inspector, is that instead of downloading images, it's downloading something, a binary something, and not the final map, the final map with a style. The idea is that the map is actually rendered client-side instead of on a distant server, and the tiles contain the bare minimum, which means it doesn't have any styling, it doesn't have even any geography, there are no coordinates. The only thing that it's aware of are geometries. So there's a square here on top of the tile. But we're still using tiles. The concept of tiles stays, only it's not an image, but a set of data. This is kind of new in cartography, so there are a lot of people experimenting with this concept of vector tiles. At CartoDB, we are doing this, which is we are using a D3 renderer. So in the end, it's SVGs on top of a normal bitmap base map. And this thing is rendered also client-side with CartoCSS. The advantage of this is that it builds on top of existing building blocks and proven technologies. The crazy guys at Mapbox have been doing amazing stuff lately, and they are taking a completely different approach where they have a new client library using WebGL, and the styling is done in JSON. And they decided that CartoCSS was at an end. A lot of people don't agree with that. It's also kind of a troll, so I'm happy to discuss this later on. Other people, Mapzen guys, are doing a lot of 3D maps, so actually showing 3D geometries, really impressive stuff. Again, WebGL renderer, except they are using YAML file format for styling, but it's also an interesting approach. And you can use a lot of these things together. It's really possible. Yeah, I'm going to skip this. So, in conclusion, this is GIS, and it's a completely separated field from front-end development or classical engineering. It's a whole separate world with its vocabulary, its community, its people, its trolls, again. And to be in this world as a front-end developer is kind of feeling like this. But it's also interesting because you come with solutions that are engineering answers to geographic problems. And you end up doing that kind of things. It's an emoji map in the terminal working with a SQL request. And when I try to explain what I do to my parents, that's not the kind of stuff I'm going to show them because it's kind of a geek thing. And so in front-end communities, there has been a lot of heated conversations lately about how it's becoming, the ecosystems are getting really complicated now, tools fatigue and that kind of stuff. So I just want to say that GIS is a completely different world, and it's also very complex. But I mean, step by step, it's easy to get on board. And I have to say that it's pretty exciting to discuss topics such as latitude and longitude with Eratosthenes and projections with Mercator, so centuries-old problems that are mixed with WebGL and very modern discussions. So it's very exciting to be in this area, especially since there's a revival of cartography in the last 10 years that is obvious, and universities in America are funding again geography programs. So it's a good time to make maps. And I think that's it. And thank you. And let's have lunch. Thanks. We have 1 minute for questions. Yeah.
So did you mean that CartoDB doesn't use Leaflet.js?
Yeah, I should have mentioned that CartoDB uses Leaflet.js. We have a library called cartodb.js, which is basically bundling Leaflet. And it's in the same spirit of building on top of existing blocks, whereas Mapbox has decided to build something from scratch. And it's really two different philosophies, but I also need to mention that it's also we are trying to solve very different problems.
So Mapbox doesn't use Leaflet? Because I thought the main developer of Leaflet works at Mapbox.
Yeah, it's continuing working on Leaflet, but the standard library now for using Mapbox doesn't use Leaflet anymore. It's a complete separated WebGL client. And it's a very high-tech piece of technology. It's very complex, but they still have like legacy products, so you can still use their own version of customized version of Leaflet, but their main product now is not using Leaflet anymore. Any other question? Perfect. Thanks.